Probability slide 01. In this session, we will introduce you to the concepts of probability. Probability has been a very regular feature in all the CAT question papers. And so, let us begin this concept in the right earnest.
What does the term probability mean arithmetically? When an action is performed, an outcome of the action results. But if the action performed may give more than one result, then the prediction of the exact result becomes difficult. For example, if a dice is thrown, then one of its 6 faces will appear on the top, and so there will be 6 possible outcomes. Probability is a study of uncertain results. There are some important terms we will encounter frequently while dealing with probability. The first among them is the term experiment. Any action which produces results is called an experiment or a trial. For example, tossing a coin is an experiment. Drawing a card from a pack of cards is also an experiment. The second such term is called the sample space. The set of all possible and distinct outcomes of an experiment is called the sample space of that experiment. It is denoted by S. Each element of the sample space is called a sample point. NS denotes the number of elements of S. For example, consider the experiment of tossing 2 coins. The sample space is S is equal to TT, TH, HT, HH, where H stands for head and T stands for tail. Therefore, NS is equal to 4. The other important term is event. Any subset of a sample space is called an event. The sample space S of an experiment serves as a universal set for all questions related to the experiment, and an event E of the experiment is a set of possible outcomes favorable to event E. For example, in the experiment of tossing 2 coins, E is an event that at least one of the coins shows head. Therefore, E is equal to TH, HT and HH. We will now list down the remaining terms. The impossible events are: since a null set phi is a subset of every set, it is also called an event, which is the impossible event. The certain event: the whole sample space S being a subset of itself is an event called the certain event. The mutually exclusive event: 2 events A and B are called mutually exclusive if they have no sample points in common. And equally likely: 2 events A and B are said to be equally likely if either of them cannot be expected to happen in preference to the other. Example, tossing of a coin has equal chances of getting a head or a tail. Complement of an event: the complement of an event E in S is a set of those sample points in S which are not in E and is denoted by E dash. The complement of the set of certain event is a set of impossible event and vice versa. If A and B are the 2 events of an experiment, then A union B is the event which occurs if and only if A or B or both A and B occur. A union B is also denoted as A plus B. If A and B are 2 events of an experiment, then A intersection B is the event which occurs if and only if both A and B occur. A intersection B is also denoted as AB and is often called the compound event of A and B. Now, how to compute probability? Let us go through the steps of doing so. Let S be the finite sample space of an experiment. Let every outcome of S be equally likely. Then, if E is an event, then the probability that E takes place is defined as PE is equal to NE by NS, where PE denotes the probability of E. Example: find the probability of getting at least one head when two coins are tossed. Here, S is equal to HH, HT, TH, TT. E is equal to HH, HT, TH. Thus, NS is equal to 4 and NE is equal to 3. Therefore, PE is equal to NE by NS, which is equal to 3 by 4. Let A and B be the events of an experiment. Then we have 0 less than equal to PA less than equal to 1. PS is equal to 1. P phi is equal to 0. PA plus PA dash is equal to 1. PA union B is equal to PA plus PB minus PA intersection B. PA intersection B is equal to PA into PB if they are independent events. If A and B are mutually exclusive events, then PA intersection B is equal to 0. That is, PA union B is equal to PA plus PP. We will now learn a particular type of probability called the conditional probability. In case of some events, the probability that an event A takes place will depend on whether another event B has or has not taken place. For example, suppose two cards are drawn from a pack of cards, one after the other, without replacement. Let A be equal to the event that the first card is a spade. Let B be equal to the event that the second card is a spade. Let C be the event that the first card is not a spade. The sample space of the event B consists of 51 sample points as the first card is not replaced and there are 12 spades to choose from. Probability of event B when event A has taken place is equal to P B oblique A, which is equal to 12 oblique 51. If event C has occurred, there are 13 spades left to choose from. Probability of event B when event C has taken place is equal to P B oblique C, which is equal to 13 oblique 51. The conditional probability of an event B given the event A is denoted by P B oblique A and is defined as P B oblique A is equal to P A intersection B oblique PA, where PA is not equal to 0. Similarly, PA oblique B is equal to PA intersection B oblique PB, where PB is not equal to 0. For example, suppose two cards are drawn from a pack of cards, one after the other, without replacement. Let A be the event that the first card is a spade. Let B be the event that the second card is a spade. Now A and B are independent events. PA is equal to 13 by 52. PB is equal to 12 by 51. PA intersection B is equal to PA, PB is equal to 13 by 52 into 12 by 51. But P B oblique A is equal to P A intersection B oblique P A. Therefore, P B oblique A is equal to 13 by 52 into 12 by 51 into 52 by 13. Therefore, PB oblique A is equal to 12 by 51. We will now go through the concept of independent events. The conditional probability P B oblique A of an event B, given that event A has occurred, is in general not the same as the unconditional probability PB. But if P oblique A is equal to PB, then the event B is independent of the event A. For two independent events A and B, PA intersection B is equal to PA into PB. PA union B is equal to PA plus PB minus PA intersection B. PA intersection B is equal to PA into PB if they are independent events. If A and B are mutually exclusive events, then PA intersection B is equal to 0. That is, PA union B is equal to PA plus PB. Let us now understand the difference between mutually exclusive events and independent events. If event A happens, then event B cannot, or vice versa. The two events, it rained on Tuesday and it did not rain on Tuesday, are mutually exclusive events. For example, event A is that Anshu goes to a 6 o'clock show of Wanted on Tuesday. Event B is that Anshu goes to a 6 o'clock show of Dabang on Tuesday. These two events are mutually exclusive as Anshu cannot be watching two different movies at the same time. Thus, PA intersection B is equal to 0. That is, probability of both A and B occurring together is 0. The outcome of event A has no effect on the outcome of event B, such as, it rained on Tuesday and my chair broke at work. You're effectively saying what is the chance of both events happening, bearing in mind that the two were unrelated. For example, Anshu goes to watch a movie. Event A is that Anshu watches Wanted. Event B is that Anshu buys a cold drink. These two events are independent as the outcome of event A does not affect the outcome of event B. Thus, PA intersection B is equal to PA into PB. So, if A and B are mutually exclusive, they cannot be independent. If A and B are independent, they cannot be mutually exclusive. What is the probability of getting at least 1 6 in a single throw of 3 unbiased dice? We have to choose the correct alternative. Find the number of cases in which none of the digits show a 6. That is, all 3 dice show a number other than 6. 5 into 5 into 5 is equal to 125 cases. Total possible outcomes when 3 dice are thrown is equal to 216. The number of outcomes in which at least one die shows a 6 is equal to total possible outcomes when 3 dice are thrown minus number of outcomes in which none of them show 6, which is equal to 216 minus 125, which gives 91. Therefore, the required probability is equal to 91 by 216. Hence, the correct alternative is option 5. What is the probability that a 2-digit number selected at random will be a multiple of 3 and not a multiple of 5? There are a total of 90 2-digit numbers. Every third number will be divisible by 3. Therefore, there are 30 of those numbers that are divisible by 3. Out of these 30 numbers, the numbers that are divisible by 5 are those that are multiples of 15. That is, numbers that are divisible by both 3 and 5. There are 6 such numbers: 15, 30, 45, 60, 75 and 90. We need to find out numbers that are divisible by 3 and not by 5, which will be 30 minus 6 is equal to 24. So 24 out of the 90 numbers are divisible by 3 and not by 5. Therefore, the required probability is 24 by 90, which gives 4 by 15. And hence, the correct alternative is option 2. Two squares are chosen at random on a chessboard. Now, what is the probability that they have a side in common? The number of ways of choosing the first square is 64. The number of choosing the second square is 63. There are a total of 64 into 63 is equal to 4032 ways of choosing two squares. If the first square happens to be any of the 4 corner ones, the second square can be chosen in 2 ways. If the first square happens to be any of the 24 squares on the side of the chessboard, the second square can be chosen in 3 ways. If the first square happens to be any of the 36 remaining squares, the second square can be chosen in 4 ways. Hence, the desired number of combinations is equal to 4 into 2 plus 24 into 3 plus 36 into 4, which gives 224. Therefore, the required probability is equal to 224 by 4032 is equal to 1 by 18. And hence, the correct alternative is option 1. When 2 dice are thrown simultaneously, then what is the probability that the sum of the 2 numbers that turn up is less than 11? Now, instead of finding the probability of this event directly, we will find the probability of the non-occurrence of this event and subtract it from 1 to get the required probability. Combination whose sum of 12 is 6, 6. Combinations whose sum of 11 is 5, 6 and 6, 5. Therefore, there are total 3 occurrences out of 36 occurrences that satisfy the given condition. Probability whose sum of 2 numbers is greater than or equal to 11 is equal to 3 by 36, which is equal to 1 by 12. Hence, the probability whose sum of 2 numbers is lesser than 11 is equal to 1 minus 1 by 12 is equal to 11 by 12. And hence, the correct alternative is option 2. A man can hit a target once in 4 shots. If he fires 4 shots in succession, then what is the probability that he will hit his target? The man will hit the target even if he hits it once or twice or thrice or all 4 times in the 4 shots that he takes. So, the only case where the man will not hit the target is when he fails to hit the target even in one of the 4 shots that he takes. The probability that he will not hit the target in one shot is equal to 1 minus 1 by 4, which is equal to 3 by 4. Hence, the probability that he will not hit the target in all the 4 shots is equal to 3 by 4 into 3 by 4 into 3 by 4 into 3 by 4, which is equal to 81 by 256. Hence, the probability that he will hit the target at least in one of the 4 shots is equal to 1 minus 81 by 256, which is equal to 175 by 256. And hence, the correct alternative is option 4. An experiment succeeds twice as often as it fails. What is the probability that in the next 5 trials there will be 4 successes? An experiment succeeds twice as often as it fails. That is, the probability of its success is 2 by 3 and the probability of its failure is 1 by 3. In the next 5 trials, the experiment needs to succeed in 4 out of 5 trials. 4 out of 5 trials in which it succeeds could be selected in 5C4 ways, which is equal to 5 ways. And as of 4 of them are successes, they have a probability of 2 by 3, and the one that is a failure will have a probability of 1 by 3. Hence, the required probability is equal to 5 into 2 by 3 to the power 4 into 1 by 3. Hence, the correct alternative is option 3. When 4 dice are thrown, what is the probability that the same number appears on each of them? The sample space is when 4 dice are thrown simultaneously, then the total number of possible outcomes is 6 raised to 4, which is 1296. The event, which is the numerator, is the chances that all the dice show same number, that is 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6, 6 is equal to 6. Probability is equal to event by sample space, which is equal to 6 by 6 raised to 4, equals to 1 by 6 raised to 3, which becomes 1 by 216, and hence the correct alternative is option 3.
Probability, slide 25. Well, that brings us to the end of the session on probability. The concepts of probability can be strengthened by practicing more questions, and for that purpose there are a lot of questions given to you to please go through them and solve them. Till then, good luck and goodbye.